Here we go. All right, so number one. Tangent of x is 2.0. Use your calculator. So the first 6 questions, use your calculator. Use your calculator to find, what x is. To find the answers in the interval 0 to 2 pi. So you see all the multiple choice answers there. So all right, so take your calculator. See if you can find which x's make the tangent of x 2.0. Give that a try.
Mr. Heron, does the mode matter?
Yes. What does it say?
You mentioned pi, so radians.
Yeah, right. It's got to be radians. Yeah. I don't know if it's, radians. So make sure your calculator's in radian mode. Okay, so how to do this? Let me dive in there with you. So you got to do, what do we do first? Yeah, tangent inverse of 2.0, right? So you just take the tangent inverse of 2.0, and let me do that with you. But first off, make sure you're in radian mode. Okay, I am. And I'm getting 1.107. Y'all getting that? So that rounds to 1.11, which they all have that answer, huh? So the whole question is, what's the other answer? There's a secondary answer. They all have the 1.11. So how do we find the second answer?
You have to figure which 2 quadrants have tangents.
Yeah, remember how we did this? We had a process, right? So here, let me take it to a fresh screen. We got a little bit more room. So tangent of x is 2.0. We do tangent inverse of 2.0. We get 1.107. Okay, yeah, so that means that is a reference angle, isn't it? Right, because, so there's always 2, so what did I write? I wrote step number 1, do the tangent inverse, well that is step number 1 right there. Step number 1, do the inverse, and I said step 2, find the 2 quadrants where tangent, in this case, 2.0 is positive, right? If that was a negative, they wanted tangent equal to negative 2.0, I would find the 2 quadrants where tangent is negative. So what are the 2 quadrants where tangent is positive? All students take calculus. All students take calculus. So which 2 quadrants is tangent positive?
1 and 3.
Good, 1 and 3. So let me get rid of these 2. So it's going to be 1 and 3. We already have our answer in quadrant 1. That first answer we got is the quadrant 1 answer. Why? Because it's positive, huh? Mm-hmm. That's the quadrant 1 answer. Okay, so now, how do I find that? So this is a reference angle, isn't it? This is a reference angle. Now, what does that mean, reference angle? Angle what? Angle from the x with reference to the x-axis, right? So that means in the first quadrant that 1.107 is how far from the x-axis in the first quadrant is the first angle. So then we just need to find that same angle in the third quadrant, right? Because that's the other quadrant. So find the 2 quadrants, find the angle using the reference angle in the 2 quadrants. Right? So use the reference angle to find it in the other quadrant. So how do I do that? So to find that angle in the third quadrant, because I know that's the other place where tangent is positive, it's going to be where the other answer is, I've got to find that angle in the third quadrant. So let's do that. It's going to be the same amount off the x-axis, isn't it? It's going to be 1.107 off the x, right? I didn't do it from here. That would have been off the y. That's not a reference angle. They're always off the x. So you with me? So I need to really find then what that actual angle is. And when I say actual, I mean starting from 0 all the way to there, huh? That's the actual how we name the angle, starting from 0 degrees. So am I losing you? You good so far? This is one of the trickiest things. So, got the original angle, hit the tangent inverse button, find the first quadrant, find the other quadrant, which is the third, where tangent is positive, find the same reference angle in that quadrant. So 1.107 off the x is how much from 0? So how do we do it? What are we going to do?
Pi plus the reference.
Yeah, because this is pi right here, huh? Remember we learned that basically the rule is, I gave you a rule for the quadrants. I said, if you're in the second quadrant, it's pi minus the reference. If you're in the third, it's pi plus the reference. If you're in the fourth, it's 2 pi minus the reference. You might want to put that right on your 3x5 card. Remember that rule I wrote up before? No? I think I did. Didn't I write that for you guys?
Yes.
Okay, good. So now, how am I coming up with that? Because basically, if there's a reference angle, reference is always in the first at first, and then say you're here in the second. Well, that doesn't look like the same, does it? Let me do a little better job there. So what if you're here in the second reference? Then how would you find what it actually is? From here, you'd go pi, because this is pi, back up, wouldn't you? You'd go pi back up the reference. Do you see the idea how I'm getting that formula? Pi minus the reference. And if you're in the third quadrant, and you're the reference off the x, then that's going to be pi plus the reference, isn't it? And in the fourth, you're going to be all the way to 2 pi. So if I did it in the fourth here, and here's the reference. So in the fourth, you would be all the way to 2 pi back up the reference. 2 pi minus the reference. So there they are. So, all right, so going back to it, so we need pi plus the reference, 1.107. Hit the buttons on your calculator. So use the pi button. So pi plus 1.107. I'm getting 4.248, blah, 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 blah. So probably, I think just two places, 4.25. So 4.25, and of course 1.11, that one rounded, right? Those are our 4.25, there it is, D. Yeah?
Did you calculate that last part, the pi plus 1.107?
Uh-huh.
Is that still in radians?
What's that?
Is that still in radians?
Sure, yeah.
Okay.
Yeah, everything's in radians, yeah.
The whole question.
The whole question's rated, yep. Right? We good there? All is well? All right, let's go on. We're going to have 5 identities on this test. So is that true or 4? 4 or 5? I think there's 5. 4 or 5. I can't remember. We'll see that when we get to part 2. So there's 4 or 5 identities. That's out of 20 questions. So that's 1/4 or 1/5 of the exam, depending whether there's 4 or 5. So so that's a lot. That's a lot of the exam. So the identities are going to be very, very similar to that list I gave you. I'm not going to make up something wildly different than those, I promise. Remember that list I gave you, that handout? So if you never got that back, I got these, brother. You can feel free to grab them after class. I got some people didn't get that back. I've got them back there, and it's on YouTube, and the original handout is also on the website. So on the Math Excel under announcements. So it's all there. Make sure you get your homework back so you can study off of that after class. I'll just stick it over here, Steve. We don't forget, it's there. Yeah, so know those, and you'll be able to do the ones on the exam. I mean, I might make small changes, but nothing big. It's going to be those forms. So just master those. So I would go over those again. What was there, 20 of them or something like that? Just go over those again. I had to do, that's exactly what I had to do to study for all my math science exams. I would take those main homeworks, because I never had Math Excel. It was all paper stuff like that. So I would just go over the homework before an exam. I would just go over the homework I'd already done. I would just cover up my work. I would try the question again. I'd say, all right, here's one of them. I think this one's off the sheet. I assume. I don't remember exactly. And I would just try it again without looking at notes to see how well I really knew it. So that's what you got to do. Just make sure you can really do those 20. You should be good. So, all right. So it's going to be one of these guys, or maybe none of the above. So, what do we do? Any ideas? I'm open to suggestions because it's not hitting me off the top of my head. we could do what?
Multiply by the secant.
Well, this is a cosine, isn't it? 1 over secant is cosine. I could do that. I get probably common. When I see fractions, I'm thinking common denominator.
Yeah.
Yeah, probably what we need to do. Yeah, I'm not going to change cosine or anything. Yeah, so my first thought is, that's why these in particular, if you don't look these over, if you don't master these, you're going to lose a lot of points. I just want to be straight. I mean, I feel like I need to talk straight because I don't know if everybody realizes that math and science is deadly business. So basically, if between now and Wednesday you don't go over those, they're just going to sink you because they're hard. They're not easy. They're not like obvious. Or even like me, you can see right now me, I don't know right away. I mean, that should scare you because I do this for a living day and night. So if I look at that question and go, yeah, because the other ones I don't go, yeah, I just boom, boom, boom because I do them all the time. So these are harder. If you do not practice those, you will miss them almost for sure. So if between now and Wednesday you don't go over those 22 of them or whatever it was, I can't remember, because it's not obvious. There's a lot of things you could do. That's what's hard about them. They're creative, huh? There's not just one. That's why I'm promising not to make radical changes. That would be too hard, I think. That'd be too much. So I'm promising that they'll be almost identical to those 22. So if you master those 22, you'll ace these. If you don't, they'll probably sink you. And that's a quarter of your grade. It'll drop you to 75% at best if you're perfect on everything else. Do you realize how important that is? Can I make it any more serious? All right, so practice. Now, here's one of the concepts. I look at that and I go, oh, fractions probably. Again, it's creative. It's not for sure. But when I see like one fraction, one other, I go, okay, probably I got to get common denominator. Put this over 1. Got to make the denominators the same, common denominator to add, subtract. Multiply top and bottom by secant. What do you get? Secant squared over secant minus 1 over secant. Is that good so far? Everybody seeing that? I just multiplied top and bottom by secant. And now, I can combine those into one fraction. Secant squared minus 1 over secant, huh? Now what? What's that? Yeah. So when you see that secant, you want to. So you remember that when you have these on your 3x5 card, you want to have on your 3x5 those basic properties. Remember, sine squared plus cosine squared is 1. That's most important. And 1 plus tangent squared is secant squared. 1 plus cotan squared is cosecant squared. Remember those? And there was a few others too, but those are really 3 super important ones. And so as soon as you see secant squared, you want to think, oh, 1 plus tangent squared. 1 plus tangent squared. So you go back here and you go, okay, this secant squared is 1 plus tangent squared. I'll replace it. Are you tracking with me? So does everybody see what happened there? So I replaced that secant squared on the top with 1 plus tangent squared. Because that's what it says. Secant squared is 1 plus tangent squared. So now what can I do? These guys cancel. So I get tangent squared over secant. Tangent squared over secant. What's that?
Sine squared over cosine squared.
Yeah, good idea. Let's do that. Right? So now at this point, these are hard, aren't they? These are truly hard. Without practice, this won't happen. Tangent squared. So what should you do now? See, every step is like hard and creative. Tangent squared. Yeah, I agree. I agree that we should probably make that sine squared, right? Because at this point, I'm trying to match up with one of these guys, and I don't know. So tangent squared is sine squared over cosine squared over, and what's secant? 1 over cosine, kind of running out of room here. 1 over cosine. Yeah, here I need to get a fresh little bit of room here. So this is tangent squared over secant, right? Which is sine squared over cosine squared over secant, which is 1 over cosine. Good to there? And now grab that 1 over cosine. Remember, flip it up. Times cosine over 1. Remember how fractions in the bottom of fractions flip up? I think we're close. Times cosine over 1. Now we cross cancel, huh? Cosine, one of those. So we're left with sine squared over cosine. Is that one of these guys? Yeah, this thing's never in. Sine times sine over cosine. Everybody see what I just did there? Sine squared is 2 sines, right? Over cosine, and 1 sine over cosine. So that's sine tangent. I think that's there. That was not easy, was it? So that's why I tried to limit the field. I'm promising. So that must have been one. Was that one of those off the sheet?
Yeah.
Was it? What was it? Oh, number 1?
Yeah.
Oh, okay. Yeah. I remember number 1 was one of the harder ones. Yeah. So that's what I'm saying. I'm going to give you ones almost identical, in some cases probably identical to the ones off the sheet. I promise, because I know this would just be, if I just opened the field, that'd just be too hard. You know, so I'm promising it'll be exactly the same or almost identical to those 22 questions. 18, is that what it is? Thanks. Okay. I'm guessing at that number. 18 of those. So practice those. Make sure you can actually do those, right? And what that means is not just looking at it and reading over it, but taking out a blank piece of paper, taking out the handout, and trying it on your own, right? That's exactly what that means. You know, don't fool yourself, right? Make sure you can actually do it. Is that good? All right. So, other questions I can answer? Everybody okay with all those steps there at the end? Everybody track with that? That good? All right. So we'll do that at the end. So the first thing we have to do is do all the work with the true triangles, right? Remember when they do these? We make the triangles and find all the stuff we need. So you know how to do that, right? Let's dive on in. This one's quadrant 3. So go ahead and make the triangle there in quadrant 3. And basically what you need is, what do we need? They want cosine of a plus b. So we need cosine and sine. Yeah, all we need is cosine and sine for both a and b, which we have one of them. We have cosine of a, so you need sine of a now. Then over here you have sine of b, you need cosine of b. So you need sine and cosine for both a and b. You have half of it, get the other ones. Right, so let me give you a second there. So quadrant 3. Here's angle A.
I just want to mention that there's session today.
Oh, there is one today?
Yeah, from 1 to 2:30.
1 to 2:30.
Yeah.
And then there's one tomorrow.
Yeah.
1 to 2:30 as well. Today and tomorrow, 1 to 2:30. Perfect. All the help you need is there. Okay, so cosine of A. Cosine, remember the SOHCAHTOA thing? SOHCAHTOA. Cosine is adjacent over hypotenuse. So this is what? This is the adjacent side, the opposite side, the hypotenuse. So cosine is adjacent over hypotenuse. So -4 over 5. Like that. Everybody good so far? What's the other side going to be?
3.
Yeah, 3, 4, 5. We've seen it so much, huh? It's got to be 3, 4, 5. Now, technically, it's -3. If you want to do the signs right, it's back 4, down 3. Back 4, down 3. back 4, down 3. Okay, so now we need the sine. So we need the sine of A. So SOHCAHTOA, sine is opposite over hypotenuse. So -3 over 5. There's the sine. That's all we need out of that triangle. I'll show you why in a second. We good? We good so far? So, and it's always good if I was taking this test, my grade was online, I would double check the sign with the all students take calculus, you know what I mean? So all students take. I'm in quadrant 3 where tangent is positive, but everything else is negative. So sine and cosine should be negative. Cosine is negative, sine is negative. I've got it right. I'm 100% sure. You know what I mean? Do that double check thing, just to make sure. All right, let's go on over to the other side. And we'll do this one. So, quadrant 2. So, whoops. Quadrant 2 is on the left side, so I'll give a little more room here. Quadrant 2. And this would be angle B. Sine, yeah, SOHCAHTOA again. SOHCAHTOA. Sine of B, opposite over a hypotenuse. This is opposite, adjacent, hypotenuse. So sine of B is opposite root 21 over hypotenuse 5. We good there? How do we find the other side? The Pythag, our friend the Pythag, right? So we do the Pythagorean theorem there. So let's do that. So Pythagorean theorem, a squared plus b squared is c squared. And that means A, I don't know A. B is root 21 squared is c squared, 5 squared. A squared, b squared, c squared. So we get a squared, that's 21, that's 25. Subtract the 21. A squared is 4, root it. A is 2. A is 2. All right, so we got the 3 sides, did the Pythag. So now, lastly, remember we need the sine and the cosine of these angles. So we have the sine. So now we need the cosine. I don't know where to put it. Here, I'll just go over here. So we need the cosine of B. We have the sine of B. So we need the sine and cosine for both A and B. We have the sine and cosine of A, and the sine of B. Now we need the cosine of B. Cosine is adjacent over hypotenuse, right? SOHCAHTOA. SOHCAHTOA. Cosine is adjacent over hypotenuse. 2 over 5. Now double check the sign, right? Very important to double check the sign. You don't want to get that wrong after all this good work. Wouldn't that be a bummer? All positive students. Sine. Sine is positive in this second quadrant, but everything else is negative. Sine up here is positive, right? But cosine better be negative. Oh, I was going to mess that up. Cosine needs to be negative. See you, Wendy? Cosine is negative, right? Cosine is negative. Why? Because it's back and up. So this should have been actually a negative to positive. You don't have to do that, whatever. We know it's negative in the end. Good on that? Now we're finally ready to answer this question after all that. So if I can squeeze it in over here. Over here. So what was the original question after all that work? Cosine of A plus B. So the cosine of A plus B. Now this is what you're going to have on your 3x5 card, I hope. Let me go back to the, here's my 3x5 card. I think you're going to have cosine of A, well, sine and cosine, right? Let me write them both out for you there. Sine of A plus B is sine, cosine, cosine, sine. Let me get rid of this stuff here. Okay, sine, cosine, cosine, sine, A, B, and sine's our friend, right? Plus in the middle, same sign. Whereas cosine of A plus B is cosine, cosine, sine, sine, A, B. He's not our friend, minus in the middle. He's the opposite sign in the middle. Good there. So you're going to have those in your 3x5 card. So we go back and we use that. Where were we? So the cosine A plus B is cosine, cosine, sine, sine, A, B. He's not our friend, minus. So there's what we need. We need those. We need cosine of A. What's that? What's cosine of A? Negative 4/5. Bring it over here. Negative 4. Next comes cosine of B. Over here, minus 2/5. Minus sine of A. Minus 3/5. They're all negative. And sine of B. Root 21 over 5. There we go. See all that? I just plugged everything in. That's why we needed to find sine and cosine for all those. So we got sine and cosine for everything. Yeah.
Can you also write down the tangent one?
Yeah, you could write down the tangent one. You want me to write down the tangent? I never know that one off the top of my head. I have to look it up. Tangent. What was that one? 3.2. Tangent. There it is. Yeah, it'd be a good idea to have the tangent one. Tangent of A plus B is tangent A plus tangent B over 1 minus tangent A times tangent B. Yeah, they're multiplied. Maybe I'll do parentheses in the bottom, make that more clear. Like that. Yeah, so that's a good one to have as well. Now, probably you won't need tangent as much. I probably won't put tangent on the exam. I can't remember. It's already made. But I might. I usually do mainly sine and cosine because we didn't do a lot of tangent in the homework. We did a little bit. I mainly put the main stuff. All right. So we got to simplify this and we're done. Everybody good to hear? I plugged in, so we're doing cosine of A plus B. That's what they asked me. Find cosine of A plus B. So I wrote out the formula, plugged in the four things we found: sine and cosine for A, sine and cosine for B. Let's work it out now. So these two multiply going to be positive 8/25. These two multiply positive 3 root 21 over 25. Everything turns out positive in the end, huh? Because 2 negatives and 2 negatives, huh? And there we go. So hopefully that answer's there. Let's see. 8 plus 3 root 21 over there it is, huh? 8 plus 3 root 21 over 25. 8 plus 3 root 21 over 25.
Where did you get the 25 from?
5 times 5? Yeah, so I'm just multiplying top with top and bottom with bottom there in the fractions. Everybody see what I did in that last step? I'm just multiplying straight. Just 4 times 2 and 5 times 5. 3 times root 21 and 5 times 5. It's top, top, bottom, bottom. So that's a long problem. These are long ones. Good? Sine of 2 theta. So there's some more formulas you want to have in your 3x5 card. Let me go back to the 3x5 card plan. So you want to have sine of 2, I'm just going to call it, well, I guess theta's fine. It's 2 sine theta, cosine theta. And you want to have the cosine of 2 theta, which is cosine squared theta minus sine squared theta. And you want to have the tangent of 2 theta, which is 2 tangent theta over 1 minus tangent squared theta. The double angle formulas. Remember the double angle formulas? And you want to have the half angle formulas. We'll get to those in a minute. And have a packed 3x5 card. Good there. So we'll do the half angle. We'll add to it the half angle formulas in a minute. So this is our 3x5 card. Plus, whatever you want to add. But for sure these are for sure needed by everybody. We good there? All right, come on back. So, all right, so how do we do this? And then we'll sine 2 theta. We just go, okay, just use the formula, which is 2 sine theta cos theta. So that's just what the formula says, 2 sine cosine. So we can use this triangle. Remember SOHCAHTOA? SOHCAHTOA. So this is the adjacent side, the opposite side, the hypotenuse. So sine theta, so let's bring this down here. So 2 sine theta is opposite over hypotenuse, 15 over 17. And then the cosine of theta, here I'm getting, my arrows are a little off. And the cosine of theta is adjacent over hypotenuse, 8 over 17. Bless you.
Over 1, right?
What's that? And put the good, exactly. Put the 2 over 1, exactly, Kayla. Is everybody good with that? Right, when a whole number is interacting with a fraction, put it over 1, it's going to multiply the top, huh? Exactly right. Good with all that? And now 2 multiplies 15, which multiplies 8. I'm just going to go top, 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 and bottom, bottom, bottom. Just straight. When you multiply fractions, it's much easier. You just go straight, huh? Top, 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 bottom, bottom, bottom. So 2 times 15 times 8. Actually, that's 240. The bottom, 17 times 17. I think that's 289, isn't it? It's not there. I guess that one's none of the above. Did I mess up? That's right? Aren't those numbers right? We go check the answer. It's disturbing, isn't it? Is this how you feel during the test? Like, what's going on? A little nervousness at first. There we go. Good. Everything okay on that one? Questions? Yeah, so the whole number, I just go top, 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 and then bottom, bottom, bottom. Okay. So, all right, so here we go again. Tangent, it's quadrant 3. So I'm going to draw it down here, quadrant 3. There it is. Right angle, there's my theta. It's in quadrant 3. And tangent is SOHCAHTOA, as you know. SOHCAHTOA. Tangent is opposite over adjacent. Opposite, adjacent. So this is adjacent here. Opposite here. Hypotenuse here. Tangent is opposite over adjacent, so it's opposite 24 over adjacent 7. Like that. And they want me to find the sine of 2 theta. So maybe I should write that out. Sine of 2 theta, well, there's no room there. Sine of 2 theta equals 2 sine theta cosine theta, huh? Sine of 2 theta is 2 sine cosine? So that means to finish this problem, we got to find sine and cosine, don't we? Everybody tracking with me? They're asking me for the sine of 2 theta, which requires I find the sine and I find the cosine from this little tangent triangle. All right? I set up the triangle, quadrant 3. Now I've got to find the other side, the hypotenuse, do the Pythag work. So, yeah, I don't know why I started. I just don't have room. I was hoping I could squeeze it in, but it's not so. So let me rewrite it. Tangent of theta is 24 over 7. Theta is quadrant 3. Find the sine of 2 theta. Okay, so the third quadrant. Oops. So There's my triangle, there's my theta. Tangent is opposite, adjacent, hypotenuse. So tangent is opposite over adjacent. 24/7. We do the Pythag work. A squared plus B squared is C squared. 24 squared plus 7 squared is C. Is that one of our memorized ones?
Yeah.
7, 24, 25? Is that what it is? Yeah, so if you have that one written down on your, that's another thing you could add to your 3x5 card if you want. Because sometimes those come up, saves you a lot of time. Yeah, you could go like 3, 4, 5, 7, 24, 25. Is there another one? 5, 12, 13? Yeah, that one, 5, 12, 13. Those are what we call Pythagorean triples that come up a lot, right? Those are some of the nice ones that come up a lot. So yeah, so you could just use those. They're really convenient. Okay, so let's go back here then. So where are we at? So 2 sine cosine. So the sine of theta. Oh, we got to finish Pythag. Well, it's 25. 7, 24, 25. If you're not sure, you can just do the Pythag work. 7, 24, 25. There's the 3 sides. So now, what's the sine of theta? The sine is opposite over hypotenuse. Opposite hypotenuse. 24/25. Cosine, adjacent over hypotenuse. 7/25.
Both of those numbers are negative, right? Because
Yep.
Oh, good point. I'm forgetting about my signs. Yes, it's really important. No, it's so easy even for me to forget. Yeah, watch out. Thanks. So it's the all are positive. Students take. Yeah, tangent. I'm in third grade. Tangent's positive. Sine and cosine are both negative, huh? So yeah, these are both. Now I would have got lucky because the 2 negatives was going to become positive in the end, but that won't always happen. Luckily, like that. Yeah, watch out. Always double check. Good reminder. Thanks, Kevin. Yeah, just always check your whenever you draw a triangle. If you're wondering like when do I check? When you draw those triangles. Whenever you draw a triangle in a quadrant and you pull out of it, sines or cosines or tangents or whatever, double check your signs based on where you're at. Third quadrant, tangents, so sine and cosine are negative. So here we go. It's going to be 2/1 times negative 24/25 times negative 7/25. 2 negatives is positive, so just multiply top. 2, 24, and 7, whatever that is. 2, 24, and 7. 3, 36 over 6, 25. There it is. Answer C. Good? All right, 1 cosine of theta over 2 and sine. So let's go back to our little 3x5 card. There it is. So now I'm going to add to it the half angle formulas. Remember those? I kind of half remember those. Let's see. The half angle formulas. There they are. So the half angle formulas. Sine of theta over 2 is plus or minus the square root of 1 minus cosine of theta all over 2. Cosine of theta over 2 is plus or minus the square root of 1 plus the cosine of theta all over 2. And tangent of theta over 2 is plus or minus, so there's running out of room, let me move it over. Tangent of theta over 2 plus or minus the square root of 1 minus cosine of theta over 1 plus the cosine of theta. Like that. So there they are. I think that's most everything, isn't it, that we need in our 3x5 card? The other ones are trig form. I mean, whatever you want to put on from the trig equations. We'll get to that in a minute. So, all right. So there's all the half angle formulas. They all have plus and minus in front, which means you need to determine the sign based on the quadrant you're in. So we will see. All right, so let's go forward then on that. And where were we? Here. So first off, we got to draw our triangle. We're in quadrant 1. That's nice. Everything's positive, huh? So quadrant 1, put our angle theta. Sine is what? Opposite over hypotenuse. So this is opposite. This is adjacent. This hypotenuse. Opposite is 1 over hypotenuse is 4. So this is not one of our Pythagorean triples. Got to do the Pythag work here. So a squared plus b squared is c squared. A squared plus 1 squared is 4 squared. A squared plus 1 is 16. A squared is 15. Root it. So this side is root 15. And everything is positive in the first quadrant, so that's nice. So, all right, let's get down to business here. What do we need? We need the cosine of theta over 2. What's the formula for the cosine of theta over 2? It is plus or minus the square root of 1 plus the cosine all over 2, right? Yeah. Now, is it plus or is it minus? Plus. Why is it plus? We're in quadrant 1. Everything's positive in quadrant 1. Good. So it's plus. So it's plus the square root of 1 plus. Now, what's the cosine of theta? Well, over here, SOHCAHTOA, right? SOHCAHTOA. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Root 15 over 4. All over the 2. We good to there? Now we got to clean that thing up.
Is this where we split it into 2 different fractions?
Yeah, I think that's a good idea. There's a couple ways we could do this. Maybe multiply by 4. That'd probably be best. Yeah, multiply by the extra denominator. There's a few different ways, yeah. So this extra denominator right here, he's what's causing the problem, huh? He's what's making it a complex fraction. You tracking with me? Right? Because of that 4, it's fractions over fractions, isn't it? That 4 is causing a problem. So I'm going to multiply through by that 4. And these cancel. So let me hold up there for a minute. So everybody good with that? That's how you take care of a complex fraction. Fractions over fractions is you multiply all the terms by that denominator piece. So what does that give us then? That gives us the square root of 4 times 1 is 4 plus root 15 all over 8. Oh, this is a hard one. Yeah. We got a little more work to do. Good to there so far? Now it's not a complex fraction. See how it's a little better? It's not, before it was fractions within fractions, and that was a mess. So I multiply top and bottom by 4. Get it to here. Now, why can't I just stop right there? Why isn't that just good? Why don't I just look and go, hey, there's my answer. Okay, oh, it's not there. Okay, none of the above. Nope, that'd be wrong. Why? What's wrong with it? There's a square root in the bottom. Think, where? Well, there's a square root over the whole thing, which means top and bottom, which means you're not simplified yet. Did I say that too fast? In other words, this means square root of the top and square root of the bottom. Right? A root over an entire fraction means it's over both top and bottom. Yeah. Which means we have a root of the bottom, which means we're not yet simplified. Right? Everybody tracking with that? So we're not yet simplified. So let's keep going, unfortunately. Some of these are hard. Okay, we good to there? Yeah. So we got to do something about that root on the bottom. What should we do about that root on the bottom? Now you might think the best thing to do is to right away multiply top and bottom by root 8. I mean, that's not illegal, but I think that'll make it harder. You should first clean up the root 8 a little bit. then you'll have less to multiply by and therefore less to simplify by in the end. What do I mean? How do you clean up the root 8? What is it? 2 root 2. Do that first. Make it simpler first, right? Because 8 is 2 times 4, right? And the root of 4 is 2. So this is 2 root 2. Everybody okay with that step?
Yeah.
That 8 is the root of 2 times 4, and the root of 4, right? The root of 4 is just 2. Plain 2. In the front 2. Is that too quick? Let me slow it down and write it again. So the root of 8 is the root of 4 times 2. The root of 4 times the root of 2, that's 2 root 2, isn't it?
Yeah.
Is that good? So 8 is 4 times 2. Root of 4 is plain 2. Okay, so we get to here. Now we cannot leave that root on the bottom. So what do? Now we will see how we have less to multiply by now. That's why this is simpler. So I multiply top and bottom by root 2. That 2 is going to go boom. Yeah, it's kind of confusing, huh? It's going to go 8 plus 2 root 15. The bottom is 4. Is that too quick? What happened on the top first off? The 2 multiplied. Both those, right? The 2 multiplied the 4 to become 8, and he went in front of the root 15. In the root. Why? Because he's in a root like he's in a root. They're both in roots, aren't they? So they are together in a root. We all good there?
Is that the Costco glue thing?
No, the Costco glue thing says you can't cancel. So we're not talking about canceling. We're just saying they're both in roots. So here, how about this? Maybe if I did this, it would be easier for you. What if we just had 4 plus root 15? You just had a plain 2. Let me just take off those extra roots. I think that might confuse your eyes. What if you just had that on the top? What would that 2 do? It would just distribute, huh? Right? Anytime you got things with two things with a plus and multiply one thing, that's just like 4 plus x times 2 or something. It just goes to both. 8 plus 2x. You guys with me? That's just distribution. Nothing more fancy than plain old distribution. And then but the reality is it has a root over it, and that has a root over it. Okay, so they have a big root over them. That makes sense? I just distribute and keep them under a root. Now, and why is the bottom plain 4? Root 2, plain 2 times the other 2, 4. All right, that's the answer we want to look for. I hope that's there. Root of 8 plus 2 root 15. Root of 8 plus, oh yeah, that's it right there, huh? There it is. So we got it. All right, that was a lot of cleanup work at the end. Questions on that? Is it all good? All those steps make sense? Anything I can help with? We good? Okay, let's keep going. That was okay. So we want to simplify that. Now, as you see that, what do you think of when you see that? Cosine, cosine, sine, sine. Let's look back at our 3x5 card. So we see this and we go, what are we even supposed to do with this? Cosine, cosine, sine, sine. Let's look back at our 3x5 card thing here. Somewhere. Where do we see cosine, cosine, sine, sine? Yeah, right here. Cosine, cosine, sine, sine. Right there, huh? So cosine, cosine, sine, sine is cosine of A plus B. So let's go back and write that down.
Or would the other one be cosine A minus B because it's a positive?
Yeah, good job. I'll write it down the way it was at first, but you're totally right. It's cosine, cosine, sine, sine. Let's write it down here. Yeah, so you want to go back and reckon and go, oh, okay. So basically, yeah, they're giving me the right side. Right, here's the cosine, cosine. Here's the sine. They're giving me the right side. Like Chanel's saying, they're giving plus in the middle. So I got to change this to plus, and then this one will be minus, right? Because they're always opposite. Cosine's always opposite signs between the two, right? Back in the 3x5 card, you'll see that. So they're always opposite signs, right? Does everybody know what I'm talking about? If you go back here on the 3x5 card, see how cosine has plus in the middle and then minus in the formula. It's always opposite, that means, right? Where sine has plus and plus, that means they're always the same. They're both minus or both plus. So, okay. So going back here, we have this. So we go, oh, okay. So the right side's this and that. That's what we have on the right side. So the left side must be the cosine of those two angles subtracted. What's the A and the B? Yeah, the 165 and the 45. So you just stick the 165 and the 45 in there. 165 and the 45. And it's minus, isn't it? Minus, because it's the opposite. It's plus in the right side, so it's minus in the left. So that, did everybody see that big step? That means all of this is just that. That's what the formula says. If you find cosine, cosine, sine, sine, that's all just equal to 1 cosine of those two angles subtracted, isn't it? 1 cosine of those two angles subtracted. So what's that, 120? And now we can, at this point, there's no calculator, right? Sorry, 1 through 6, we had our calculator. So I'll let you use calculator on the first parts, reverse. So you'll start with your calculator, and then the part 2, starting here at number 7, no calculator. You just go to 3x5. I mean, go to your unit circle. That's right. You got to put the unit circle on your 3x5 card too, as well as all those other formulas. So if you want the unit circle, let's go get the unit circle. Bless you. Or I could just draw this one, I guess. So 120 is down here. Right there, right? Just past 9, just 30 degrees past 90. No, that's not it. That's 30. That's 210, isn't it? What am I doing there? So it's right there, huh? Right there, because this is 90 straight up, so 120 is a little past that. 90. So that is back a little bit, up a lot. Back a half, up root 3 over 2. Cosine is the x, sine is the y. What have we got? Cosine? So cosine minus a half. Done. That means all of this, all of this is just minus a half by that formula. Did you track with all that? So how did I recognize that? It's on the 3x5 card. Cosine, cosine, sine, sine. We see that and go, oh, that's just 1 cosine, angle subtracted. Go to the unit circle. We good there? Questions? Okay, take a look at number 8. Sine, cosine, cosine, sine. What does that look like? Go back to your 3x5 card piece there. See if you can do that. It'll be almost just like the last one. How we doing? So we see sine, cosine, cosine, sine. That's the sine. It says sine of a plus b is sine, cosine, cosine, sine, right? But ours has minus in the middle. So that means change both these to minus. Remember, sine's the one that the same sign. Negative with negative, positive with positive, right? Cosine switches the sign on you. See, it's more tricky. Okay, so we see the right side. So therefore, all of this is like the right side, which is equal to just 1 sine with those two angles subtracted. 260 minus 20. Sine of 240, you can go to the unit circle. I'll just draw it right here real quick. 240, that's what? Almost 270. Here's 270. 240 is there. So that's what? Back a little bit, down a lot. Back a half, down root 3 over 2. This is cosine is x. Sine is y. We want sine minus root 3 over 2. There it is. We good? Is that making sense? Questions? All right, I'm going to keep. Okay, so how do we, so they want us, because 280, what we can't, 285 is not one of the ones on our unit circle. So this is the part 2 where you don't have your calculator. That's not one of the values on the unit circle. So how are we going to find it? Well, it's telling us to write it as 2 angles added or subtracted. So basically 2 angles that are easy for us. Can you think of 2 angles that are, ones we do a lot of, that are on the unit circle, that add up to be 285?
240 and 45.
I think that's what comes to my mind right away is 240 and 45. There's other ones. We could do 180 and... No, that wouldn't work. Yeah, this is the main thing. 240 we use a lot, 45 we use a lot. Those are nice ones. Yes, let's go with those. Is that good? So they're telling you, write it as 2 angles added or subtracted. We could do something as, no, that wouldn't work.
315.
Yeah.
30.
Yeah, 315 minus 30. Yeah, that'd work. You could do 315 minus 30. That works too. All right, anyway, let's keep going. So cosine and 2 angles added. Again, our 3x5 card. We'll say cosine, cosine, sine, sine. You put the 240, the 45, the 240, the 45, and cosine always is not our friend, as my old buddy used to say. Opposite sign. So we cosine plus there, minus here. Everybody good? Cosine always does opposite sign, doesn't it? So we get that. Okay. Now we just got to go find all those on the unit circle. So on the unit circle, we go to here and find the cosine of 240. Where's 240? Almost to 270. So 240. So that's the one that's back a little, down a lot, back a half. Down root 3 over 2, that's cosine, sine, and the other one's 45. 45. Yeah, 45 is right here in the middle, huh? 45. Yeah, that's over medium, up medium, over root 2 over 2, up root 2 over 2. Oops. That's a sine, cosine. Okay, so we can put it all together now. Cosine of 240 is minus a half. Cosine of 45 is root 2 over 2 minus sine of 240 minus root 3 over 2. Sine of 45 root 2 over 2. Everybody good with that? I got all those values. You just plug them in. And there's the minus that's between them as well. So clean that up. So these multiply. Now, when you multiply fractions, just go straight, right? Top, top, bottom, bottom. So 1 root 2 over 4. Minus and minus plus. Oh, I forgot the minus there, didn't I? It's minus 1 root 2 over 4. Be careful. Don't mess your signs up like I just did.
You could just do minus root 2 over 4, right?
Yeah, the 1's not needed. That's true. So there we go. There we go. So let's go look for that answer. Oh yeah. Yeah, look at that. Okay, hold on. Everybody good to there so far? Everybody good to there? Now, as I go look at those, and none of them are there. Now, there's a couple that are similar. We have a 4 in the bottom. There's this one with the 4 and that one. They look like maybe But they're in a different format, aren't they? Right? Here's our answer. And then we look at theirs, and there's different. What should you do? We need to find out if those are algebraically the same. Do you know what I mean? So let's take the first one. It's got a minus sign in the front, root 2 times root 3 minus 1 all over 4. I got to find out if that's the same as my answer, which I have right here. So I don't have any parentheses, do I? So what I could do is I could just take, theirs and FOIL it out. Just take that root 2 and go boom, boom. What are we going to get? Root 6 minus root 2 all over 4 with a minus in the front. It's kind of like mine. Let's try the other one. How about this one? Same kind of thing. We got a root 2, root 3 minus 1 all over 4. Let's FOIL that one out and see what we get there. So root 3. So here we go. Boom, boom. I get root 6 minus root 2 all over 4.
It's the same thing.
And that was negative one.
Oh, I see.
So they're very similar except for the negative sign. Now, which is right? Are they the same as mine? See, root 6 minus root 2. Root 6 minus root 2, D. Do y'all see that?
So the
Yeah.
authors just
Kayla.
factored out
Yeah, they just factored it.
because they have you put square root of 2 in the front because that's what they have in common, right?
Yeah. Now you don't have to do that. They just happen to do that. Yeah. Yeah, like, why did they do that? Well, they just did. You know, it's a language. You can say the same thing like any language, right? It's a synonymous way of saying the answer. It's another way to say the same thing. So do you see that? I don't want you to get tricked on the exam. I just grabbed these off the publishers. You know, I make these tests by I just told it to give me one of these add two angle problems, and this is the way they made the answers. So, but I'm trying to help you to. It is valuable though. You guys are moving on into pre-calc and calc if you are going that way. Is to know when something's the same in the language of algebra. Is that okay? Feel like you could do that on the exam? Just multiply out that top there. So if it looks really similar, thinking I got this, how do I know if it's the same? I don't have parentheses. They have parentheses. A and D look similar. Distribute them out. D is the same. D is the same as what we got, isn't it? We good there? Questions? So, all right. Okay, so what do we do with cosine added? We have that formula, huh? Which is from the 3x5 card. It's, here, let me bring it down here. It's equal to cosine, sine, sine, and you put in the angles. 135, 120. 135, 120. And cosine, does he keep the same sign or the opposite? He's always opposite, yeah. So if it's plus in the original, it's minus in the formula. So yeah, opposite. And so then you just go to the unit circle, find those four values and plug them in. It's a lot like the last one. So let me do the little unit circle thing over here. So unit circle. So 135, 120. So 120 is right here. And so what is that? That's back a little bit, up a lot. Back a half, up root 3 over 2. So back a half, up root 3 over 2, cosine sine. And then for the 135, which is right here, 135, you know that's back root 2 over 2, up root 2 over 2, cosine sine. Everybody good there? 135, right? That's halfway. You just go to the unit circle, find those values, back and up. So, all right, so we plug in our four values. Here we go. Cosine of 135. Watch your signs. Back root 2 over 2. cosine of 120, back a half, minus sine of 135, that's root 2 over 2. Sine of 120, that's root 3 over 2. Good with all that? Let's plug everything in. Okay, so let's multiply that together. So this is 2 times 2 is 4. So I'm going top times top, bottom times bottom. So that's going to be 2 negatives. Positive root 2 over 4 minus root 6 over 4. Looks like the other answer, doesn't it? Good, we'll see if they've got them all factored again or something. Everybody get to there? Okay with all the signs? Be really careful with all your signs. Let's go back. Yeah, they got them all factored again. So we're going to have to find which one's the same as our answer. Let's see. So it's over 4, so I'm only going to... Well, they're all over 4. That didn't help. I thought I would help with that. All right, well, let's just start multiplying them out. Boom, boom. This is root 6 plus root 2 over 4. Boom, boom. There's a minus in front here. Root 6 minus root 2 over 4. Boom, boom. Root 6 minus root 2 over 4. Boom, boom, with a minus in front. Root 6 plus root 2 over 4. Okay, what do we have? We have a minus in the middle, but no minus in the front. Minus in the middle, no minus. Yeah, C, huh?
It would be D, right?
Oh, you're right. Yeah, hold on. This is super tricky. Yeah. Here's another principle from algebra that we got to keep straight. The order on things never matters. It's just the sign in the front, right? So if I had like negative x plus 2 or right 2 minus x, those are the same thing, aren't they? Why? Because there's a negative in front of x, negative in front of x. Positive in front of 2, nothing in front of 2, which means positive. The order never matters. You can move things around all day long as you keep the sign in front of them, off to their left. With them, wherever they may go, it's all good, right? Okay, so what that means is, oops, let me get back to this. This is going to be the same as if you reordered these and put the minus root 6 in the front and the plus root 2 over 4 in the back. That's the same thing, right? That minus has got to go with that root 6. That's his baby, wherever he may go. That belongs to him, right? So that's the same answer. Okay, so which one has that? Minus root 6 in the front. Well, see this minus in the front? Yes, and this is the other principle you need to know from algebra. What does a minus in the front of a fraction do? You can put it on the top or the bottom, and when it goes to the top or the bottom, it'll go to everybody up there, not just the front part. Huh. So when this minus goes up top, it goes boom, boom. Minus root 6 plus root 2 over 4. That's our answer. Okay? Yeah. It's B. Yeah, let's try D. Take that minus, boom, boom. Get minus root 6 minus, both minus. We don't have both minus. You enjoying this? So let me pause on this for a minute and help. Everybody see what's happening here. So yeah, so to convert all these weird forms of the answers to our forms, what should you do? You didn't, by the way, come back over here. You didn't have to reorder these. I would probably just leave it like that. You don't have to reorder these. You just got to fiddle with their answers. So come back over here. And so one more time on this. So you distribute the tops. So here in the purple, I distributed all the tops. And then what does the minus in the front do? Goes to the top and hits them both. Goes to the top and hits them both. So it's minus root 6 plus root 2, or minus root 6 minus. We have minus root 6 and plus. So our answer is B. Everybody seeing that? Does that make sense? So minus in the front of a fraction distributes to the top, changing both the signs on the top. Is that good? All this is prepping you if you want to go down the math science road and want to go to calculus eventually. All these rules are everywhere. And this is what will make, if you got these rules down well, calculus isn't that hard. It's just all this kind of stuff, So if you get these down well now and in pre-calc, calc is not that bad. It's just all this, with just a little extra cherry on the top. It's just all this algebra, though. Are you good with negatives and fractions and roots and all that? If you are, calculus is not that big a deal. It's just algebra on steroids. It really is. It's just pumped up algebra. So that's why, we're doing all we can to make you stronger and stronger with all these rules from algebra, because that's what it takes. So if you get those down good, calc isn't that bad. All right, let's keep is on YouTube already. So let's just go forward. So 15, write the expression sine, cosine, double angle, find the exact value. Da-da-da. Okay, so 15, cosine squared 22.5, cosine squared 22.5 minus sine squared 22.5, right? Yeah. Write the expression of a double angle. Okay. What are they talking about? So, where do I see cosine squared minus sine squared? That's probably the main thing we should think. We see cosine squared minus sine squared. We go back to our 3x5 card, right? Let's go back there. 3x5 card. Oh, whoops, I hit the wrong button. Where am I? Cosine, where is, way back here now. 3x5, where are you? There it is. Okay. Where do we see cosine squared minus sine squared? Right there, huh? Cosine squared minus sine squared. So cosine 2 theta. All right, let's go forward. So we're remembering cosine of 2 theta equals cosine squared minus sine squared. Okay, so what? So y'all with me? We're going to do this. This is a little bit tricky. It's not that hard, but you got to recognize it. So, to see the relationship that exists there, math is all about patterns. Look at the pattern there. So let me write for extra clarity. Let me just write the right side right here. 22.5 sine squared 22.5, and then I'm going to figure out the left side. Good so far, right? I'm just matching up the question they gave me with the right side of the cosine 2 theta formula. I just see it on my 3x5 card. You'll have those right on your 3x5 card. You just look down the list, go, oh yeah, there it is. Okay, then just match it. It's a pattern. Math is all about the pattern. So what's the pattern there? Over here, on this left side, it's going to go cosine of 2 times something. Times what? Whatever you see over there, yeah, 22.5. Maybe I'm making too much of it. It's just like that. Is that good? So that's the exact pattern, right? They're saying whatever angle you have on the right side, when you have cosine squared minus sine squared, just take that angle and put it in right there, and it'll be cosine of 2 times that is 45, which is root 2 over 2, done. Once you match up that pattern, it's an easy question. Let me talk about that a little bit more. Does everybody see what happened there? So when you see cosine squared minus sine squared, you realize that's the right side of one cosine of 2 times that angle. So 2 times that angle is 45. 1 cosine of 45 is just root 2 over 2. For the unit circle, right? 45 right there. So that's over medium, up medium. Root 2 over 2. Root 2 over 2. Cosine sine, you know that one from the unit circle quite well. That's a cosine. Cosine sine. We good? Getting the hang of this? Degrees, right? Because radians sometimes mess me up. So let's just change that to degrees. Pop in a 180 there. It's going to be 3 times 180 over 8. 3 times 180 over 8. So... yeah, so can we simplify that? It's a little messy, isn't it? 3 times, yeah, just, there's no calculator in this part, so this would all be by hand. Can you multiply and divide by hand still? It's been a while since you've done that, so it's a little painful. So I'll do 3 times 180, 24, 540, good so far? That's the top, divided by 8. So this is 540 divided by 8, long divide, 8 into 540. Can you long divide by hand? Has it been a while? 8 into 5, 40. What's that? 6 times 8, 48. Remember your times tables? A little rusty.
7.5.
Is that what it is? 5, put a 4, put a 1. This is 6. Bring down the 0. 60. Remember long division by hand? Remember all this? 8 goes into 60. What's that, 7 times? 7 times 8 is 56. Subtract 4. What do you do now?
You have to just put a point 0.
Put a decimal point 0. Bring down the 0. Remember? Yeah, remember how to do this? Everybody good with me there? Remember, when you get to the end of the number, you got to add a decimal point 0, bring it down. 8 goes into 40. And the decimal goes straight up too, doesn't it? Remember, they're all lined up. And 5 times 8, 40. So 67.5. So this is the cosine of 67.5 degrees. So you figure that out by hand, a little multiplying and dividing. 67.5. Now, what are they wanting me to do? They're saying rewrite it by half the double value. Do you realize half the double value is the same as the original value? Right? That's just a weird. No, you think, why? Why? We'll see why in a minute. But first, I have to get the idea. Half the double. So what's the double? Whatever 2 times 67.5 is. Let's multiply by 2. Here. 2 times 67.5. 2 times 5 is 10. 2 times 7 is 14. Add 1, 15. 2 times 6 is 12. Add 1, 13. And the decimal goes back one place. Am I going too quick? Remember this old by hand, multiplying, dividing, decimals, fractions stuff? Everybody good there? Everybody see what I did? So I just doubled 67.5. Right? Got 135 degrees. Okay, so what are they wanting me to do? Rewrite it as half the double value. So they're saying cosine of, instead of 60.75, half of 135. That's the same as 67.5, isn't it? Half the double value. Now, why? Well, because now I can use the half angle formula. See, I couldn't get cosine of 67.5. 67.5 is not one of the ones we know. That's not in our unit circle. But 135 is. But I got to use the half angle formula and then look up 135. Are we good so far? So all I've done really so far is a bunch of by hand work. I took 3 pi over 8, right, and I put in the 180, the 180 degrees. By hand figured out it's 135, or it's 67.5. And then I doubled it, so it's half the double value. They're giving me that hint. Half the double value. All right, so now let's get rid of this by hand work. And so now let's use the half angle formula. So if you go to your 3 by 5 card, because this is a half an angle. So what does the half angle formula say? The cosine of theta over 2. That's the same thing as a half times theta, isn't it? Theta over 2 is a half theta. Is plus or minus the square root of 1 plus the cosine over 2. That's the half angle formula. Okay. So this is going to equal plus or minus the square root of 1 plus. Now, what's the cosine of theta? Yeah, what is the theta first off? Is it the 67.5 or the 135?
67.5.
Look at the formula. Look at the formula with me. It's math is patterns. Just really carefully observe the pattern. They're saying what angle you have here over 2, that angle goes right there, right? Theta, theta. So it's the 135. That's the thing over 2. Half is the same as over 2, as you know. Theta is 135. This is cosine of 135. Everybody see that?
Yeah.
That's the pattern, isn't it? Right? See how that's what math is all about, is being more and more careful with patterns. So the theta is 135 in that formula. That's how we use the half angle formula. Whatever angle's on the top, that goes right there. Now, what is the cosine of 135? Yeah, if you go to the unit circle, I don't want to use up any more of our time. It's going to be root 2 over 2. You good to there?
It would be negative root 2.
Oh, it is. It's negative. Thank you. So that'll be negative root 2 over 2. Everybody good so far to there? Negative root 2 over 2. Now, what about the plus or the minus in the front? This is where it's extra tricky. And you got to be really thinking clearly. So remember what equals this. This is the, where did it all start off with? It's the cosine of a half times 135 over 2, if you want. Whatever. Same thing. Right? We good so far? Is it plus or minus? Well, think with me. What angle are we really taking the cosine of? This angle. This whole angle is being put into the cosine machine, isn't it? That's what we're really taking the cosine of. Are you tracking with me? What is that? Well, 67.5. Where's 67.5? What quadrant? Quadrant 1. It's plus. But if you looked at the 135 mistakenly, you would have thought, well, that's second quadrant, cosine's negative. And you would have been wrong. The actual angle, what are we really trying to, what are we really figuring out here? From the very beginning, this was 3 pi over 8, which we found to be 67.5. We are really finding the cosine of 67.5, aren't we?
Yes.
That's the real question, which is first quadrant. So you always got to be clear, what is the actual, now, we use 135 because that's what the formula says. The formula says if you have some angle over 2, then you can do this little tricky thing with the double that angle. You know, that's what it says. But the real angle we're finding is 67.5. First quadrant, everything's positive. Good? So now we just got to clean that up. So let's go to a fresh screen, clean that up. So, whoops, we're getting positive square root of 1 minus root 2 over 2 all over 2. Did I get that right? Okay, good. Okay, now clean that up. You know what to do. What do we do? Yeah, see this guy right here is the problem, huh? So you multiply everybody top and bottom by that 2, and he cancels out, doesn't he? With me on that? They got to get that extra denominator to cancel out. So what do we get? Positive the root of 2 minus root 2 over 4. Oh, good. This one's going to go a little nicer. Is that good to there so far? And now what do we do when we have a root over an entire fraction? Root the top, root the bottom, right? Root over an entire fraction means root of the top, root of the bottom. And the root of the 4 on the bottom is just 2. There we go. I'm hoping that answer will be there. It's not. Root of 2 minus root 2. Let's see, root of... Oh, they have the halves in the front. 2 minus root 2. Okay.
Wouldn't it just be the same as that thing times?
Yeah, so are you good with the fact that dividing by 2 is the same as a half, multiplying by half? Whoops, I'm getting it all scribbled up here. It's the same as a half times the root of 2 minus root 2, isn't it? That's the same answer. Right? Dividing by 2 or multiplying by half, same thing. So isn't that B? There it is. A lot of algebra lessons, huh? Valuable algebra lessons if you're wanting to go to higher math. Questions on all that? We good? All right. So what do we do to solve that thing? How do we solve for x?
Minus square root of 2.
Do what's that?
Minus square root of 2.
Yeah, move that, subtract it, move it over. I'm just going to jump it, but yes, subtract it, same thing. Very good. So 2 sine minus root 2. Next step. Divide by the 2. Boom. Come on down. Sine of x is minus root 2 over 2. All right, then we go to our unit circle, right? Find out where is sine negative root 2 over 2. It's going to be 2 places. Let me go there with you. See if I can find it. I don't know where my unit circle is. There it is. So where is sine minus root 2 over 2? So cosine sine, cosine sine, cosine sine.
5 pi over 4 and 7 pi over 4.
Yeah, good job. I'm going to cut to it. Cosine sine right there and cosine sine right there. 5 pi over 4 and 7 pi over 4. Those are the 2 places where sine is minus root 2 over 2. We good? 5 pi over 4. You're going to have that unit circle for sure on your 3x5 card, right? 5 pi over 4, 7 pi over 4. So we come on back and we go, okay, x is 5 pi over 4 or 7 pi over 4. But you can tell by the answers, they have a bunch of that 2 in pi. So you just throw a 2 in pi on both those. 2 in pi. So 5 and 7 pi over 4 plus 2 in pi. Where's that one? D. There it is.
When do you have to do that? It's when it's like something x, right? Like 2x or 3x?
That's one of the times, or when they say all solutions. Yeah. Yeah, for sure when they say 2 or 3x. We'll get to one of those in just a second. So I think you wouldn't have any trouble recognizing. You'd see the 2 in pi's there in the multiple choice, so you know. So that one's not a problem. All right, let's look. See 2x. So let me write it out. So cosine 2x equals root 3 over 2. Root 3 over 2. Yeah. So yeah, let me just write a note. When you've got 2x or 3x or 4x or something like that, you must do the plus 2 in pi, 2 in pi, and the n equals 0, n equals 1, n equals 2, dot, 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 up to 1, come on, up to 1 less than original number x, huh? You tracking with me? Remember that? So that's when you have to do that whole thing. When you have 2x or 3x or 4x, like we do in this one, that's when you must do the plus 2 in pi. That says 2 in pi. I write all scribbly and then spend a whole bunch of time fixing it. So whenever you have the 2 in pi, and then you got to do the n equals 0, 1, 2, up to 1 less than the original number that was next to x. Right? So if you have 4x, you're going to go up to 3. If you have 3x, you're going to go up to 2. And if you have 2x, you're only going to do n equals 0 and n equals 1 in our problem, huh?
Okay.
Remember that? So there's going to be one of those, I'm sure, on the exam, like there is one here. So, all right, what do we do? First off, we go to the unit circle. Where's cosine root 3 over 2? I don't know. Where's cosine root 3 over 2? Oh, right there and right there. Yeah, pi over 6 and 11 pi over 6. Cosine sine and cosine sine. So pi over 6 and 11 pi over 6. Good so far. So we go back and go, okay. So that means, but careful, that's 2x, which is pi over 6, and 2x, which is 11 pi over 6, isn't it? Plus 2 in pi. Plus 2 in pi. Good so far? Remember how this works? So you find those 2 spots in the unit circle, pi over 6 and 11 pi over 6, and then and since it's a 2x, we got to do the plus 2 in pi, and what do we do first? Good. First divide by that 2. We don't start doing the n equals 0, 1, 2 yet until you first divide. You got to get x alone, huh? Good. Divide through by 2. Now how do we divide that right side by 2? And you got to multiply that denominator by 2 and divide this by 2. Right. Same thing on the other side. Divide by 2, denominator times 2, and divide by 2. Cancels. So x equals pi over 12 plus, these cancel, n pi. And over here, x equals 11 pi over 12 plus the 2's cancel, n pi. Everybody good to there? Is that making sense? So pi over 12 plus n pi, and 11 pi over 12 plus n pi. Now, so we got x alone in both cases. Now we do the n equals 0, n equals 1 stuff. So we go, okay, n equals 0. That's going to be just pi over 12. And over here it's just 11 pi over 12. There's two answers. And then n equals 1's a little harder. Yeah, it's going to be pi over 12 plus 1 pi. And this one's 11 pi over 12 plus 1 pi. We got to do the common denominator thing on those. Remember that whole thing? Got to do that. So let's do it. These are over 1. Multiply top and bottom by 12. Top and bottom by 12 to make the common denominator 12 on that. And then what do we get from there? Pi over 12 plus 12 pi over 12, 13 pi over 12. Over here, we get 11 pi over 12 plus 12 pi over 12, 23 pi over 12. There's our four answers. That making sense? Everybody see how we do that? So there'll be one of those on the exam, where you have the 2x, 3x, 4x kind of thing. Got to go the plus 2n pi, divide through by 2, let n be 0, n be 1, common denominator. So I'm sure, where is it all for? Is it this one?
C.
There it is. So how am I, so this one is just regular x, no 2x here or anything like that. So what am I going to do? So what's his issue and how do I handle it? Yeah, because the main thing that jumps off the page, you need to jump off the page for you there, is we will need to factor it in a minute. That's certainly true. Right now, though, the first issue is there's a mix of sine and cosine. We can't have that. It's got to be all sine or all cosine. We can't have a mix. So, right, does everybody see? If I tried to factor right now, it just wouldn't work. So you got to make it all one of them. What are we going to do? Remember those formulas? Sine squared plus cosine squared is 1. Remember, we can use that one lots of ways. If you jump sine squared over, you get cosine squared is 1 minus sine squared, or vice versa. Right? Remember that one? He's super, we use him a lot. So whenever you see cosine squared and regular sine, that's when you think, oh, just replace this guy. It's always the squared one. We never mess with the regular. I'm not going to replace the regular sign. We don't have any formulas involving regular sine or regular cosine. That stays. But the cosine squared, that can be replaced with 1 minus sine squared, huh? So this will become 2, and then we replace cosine squared with 1 minus sine squared. Plus sine x minus 2 is 0. Everybody see that? See how I replaced cosine squared with 1 minus sine squared? So that's what we do when we have a mix of sines and cosines. We replace the squared piece. And that can go either way. You can replace cosine squared with 1 minus sine squared, or vice versa. Sine squared with 1 minus cosine squared. All right, now let's distribute. Boom, boom. 2 minus 2, I'm going to just go s squared, because it's just all sine now. We get to there. Get to there. Time's a run in here, so let me go quick. 2 minus 2 cancels. Minus 2 sine squared plus sine is 0. I think it's easier to have positive in the front. You don't have to, but I think it'd be easier for you. So what can I do to make that have positive in the front? Multiply through by -1, -1, -1. And so what do we get? 2 sine squared minus sine is 0. And I multiplied through by -1. And now what do I do with that thing?
Divide. Both sides.
Factor. Now we factor, right? How do I factor 2 sine squared minus sine?
2.
Take out a sine. Right, maybe I'll go back to just calling it sine x. 2 sine x minus 1, right? See if that multiplied, it would go back, huh? Everybody good with that? Remember the general game plan, get a zero factor? We kind of often end up going to that, don't we? So get a zero factor, and then what do we do from there?
Both sides equal 0.
Yeah, each part equals 0, huh? So the first sign alone is 0, or the second, because if two things are timesing to be 0, either one could be 0 to make that happen. Keep going. Jump the 1 over. 2 sine is 1. Divide by 2. Boom. So sine is 0. Sine's a half. Go to the unit circle. Sine 0 will tell you, where's sine 0? 0 and pi. Sine is a half on the unit circle.
Pi over 6 and 5 pi over 6.
Pi over 6, 5 pi over 6. Those four answers, 0 pi, pi over 6, 5 pi over 6. There it is. On that, we good on that? 1 minute left. Let me just start you on 20. Well, yeah, we got, is that good to there? Questions on that one? So what am I going to do on this one? Same exact thing, right? Sine squared is 1 minus cosine squared. See that? This right here becomes that right there. Just like the last one. Sine squared can be replaced with 1 minus cosine. Why? Because we got to get it all cosine or all sine. You go the other way, it doesn't matter. It's probably the easiest. Like that. Remember that? When you have a mix, you got to get it all in one kind of thing. And then that's 1 minus 2 cosine squared. And then how do we finish that? Our last 15 seconds here. Jump that over. It becomes positive 2 cosine squared. Got to get the cosine alone. Divide by 2. A half is cosine squared. How do you turn that into regular cosine? Square root it. When you put a roof on the house, up and down the ladder, plus or minus. Remember all this? Sorry, I know I'm flying at this point. Cosine is plus or minus a half. What do you got to do with plus or minus the root of a half? That's the square root of 1 over the square root of 2. We can't have a root on the bottom. Multiply top and bottom by root 2. It's plus or minus root 2 over 2. Go to the unit circle. You'll find 4 answers.